Are we live? I think we're live, guys. Hello, hello, welcome, welcome. Hello, hello, let me know, guys. Can you hear me? Can you see me? Not see me, sorry. Can you see the screen? I mean, give me 1 second just to obviously get this downloaded. Actually, give me 1 second, guys. Sorry, let me just pause it for a second. There we go. I think we're back up and running now. Hello, hello, welcome, guys. Hello, hello. Hello, hello. Hope you're well. Let's just double check that you can hear me. Okay. So, welcome to our first, okay, A-level, live stream, okay? I was meant to obviously do it on YouTube, but there was some technical glitches, so apologies about that. Okay, hopefully you can still obviously catch me, okay? But yeah, let me know, guys. Can you hear me? Yeah. Let me know, okay? Hello, CS. Welcome, CS. Okay, welcome, my friend. Welcome, welcome. Hello, hello. Okay. Hello, Joe Corey. Welcome, my friend. Hello, hello. There we go. Hello, Kieran. Welcome, my friend. Welcome, welcome. Guys, sorry about the YouTube issue today, okay? I was meant to obviously go live actually on YouTube, but there was an issue on my end. I apologize about that. Hello, Kayud, or Kayud, is that right? Okay, guys, anyone from YouTube, guys, please tell them, hello, Cheryl, welcome, welcome. We are obviously doing the live today, on TikTok. Okay, hello, Grace's, Maxims, I think that's right, or Gracie, sorry. Okay, if anyone can't make the live today, that's fine. I will obviously put it up here on YouTube, straight after the stream. Don't panic. But I'll give about just 10 minutes here because obviously I made like a late announcement. I'll give about 10 minutes here and then we'll make a start. But today, guys, we're looking at some AS Pure Maths today. So this is aimed at year 12. Thank you, Ibzadi, for liking. Thank you, ISCS for liking. Hello, Ruth, welcome, welcome. But guys, anyone from YouTube, guys, please, thank you, FCRE for liking. Guys, anyone from YouTube, please, tell them, that I'm doing obviously the live today on TikTok. Okay, but I will obviously rectify, so hello, Shell, welcome, welcome. But the next live, hopefully, will be back here on YouTube only. Okay. But this is our first A-level or AS Pure Math stream of the year. Okay, for my year 12 students. Okay, online, and face-to-face. Okay, so everyone here is welcome. Okay, please share it, with anyone that's in year 12 or year 13. Or even just see further maths. Okay. So little disclaimer, this is not aimed at just C maths here, so don't panic if this is new to you. This is aimed at AS Pure Maths. Okay. Thank you, Enoch. Welcome, my friend. Welcome, welcome. Hello, hello. Hope you're well. Guys, anyone from YouTube, guys, please let me know that I'm doing this on TikTok today because of a YouTube glitch. Apologies, sorry about that. Apologize. But I'll give it just 5 more minutes here. Hello, Morgan. Welcome, welcome. Okay. Just to allow, people. Hello, Archie. Welcome. Hello, user. Welcome, my friend. That's user 364256. Okay. So AS is what they do in year 12. So in the UK, so when they start their A-level maths course in year 12, okay, so A-level maths is comprised, hello, HXX.4X, is comprised from, AS and A2. Now, the first chapter in AS covers, just C maths, so a lot of years, like recap. Hello, Catherine, welcome. Hello, Evista. Welcome, guys, welcome, welcome. Okay. So don't panic too much if it's yeah, a lot of it's recap, but this is just yeah, obviously, yeah, obviously, thank you, Aiden, one keep for liking. Hello, Fred, guys, yeah, welcome, guys, yeah, make sure tap on that screen, obviously share the live that if you can, okay, and please tell anyone that is on YouTube today to head over to my TikTok, okay, and I reckon today we can smash 20K likes, so let's try and aim for 20K, yeah, okay. I'll be live, for around an hour and a half, maybe even 2 hours. Okay. But we'll make a start, in just 5 minutes, just obviously allow time for anyone that is coming over from YouTube. Because there was a YouTube delay or YouTube glitch today. Thank you, Tiffany, for liking it. Thank you, Tiffany, for liking. Thank you, Melon Walt, for liking. Hello, Tiffany, welcome. Thank you for joining today. Thank you. Hello, Maisie, welcome. Hello, Abigail, welcome, guys, welcome. And thank you for joining today. Hello, Eve. Hello, Soph. Welcome. Hope you're well. Oh, I hope it's been a good day so far. If you're on a half term or if you're at school, I hope it's been a good Tuesday for you. Okay. But guys, we'll start at 20 past, just to allow time, for obviously others to join. Okay, but if anyone is on from YouTube, okay, please, tell them. Hello, Jack. Welcome, Jack. Hello, Sam. Welcome, my friend. Hello, BD. I'm just gonna give you just 5 more minutes here from anyone here that is joining here from YouTube. Yeah, I'm good, Simon. How are you doing? Yes, I am doing pure. Yes, Ariba. Yes. So a lot of this will be recap from GCSE maths, but it's still useful. No, it's a half three. I was the first one. Let's double check here, Mohammed. Yeah, in just a minute, okay? We'll double check. So yeah, obviously I'll try to zoom in here because obviously the numbers are quite small. I apologise. But yeah, hello Grace. Welcome, Grace. Hello. Guys, anyone from YouTube, yeah? Oh, awesome, Simon. Congrats, my friend. Congrats. Well done, buddy. I'm so proud of you. Congrats. Hello, Valerie. Welcome. Yeah, that is awesome, Simon. Yeah, that is awesome, my friend. Guys, anyone from YouTube, yeah, please tell them that tonight's live or today's live is on TikTok because of a YouTube glitch. Okay. We're going to make a start in just literally a few minutes. Hello, Love Heart. Welcome. Hello, Ella. Welcome. Hello, Jay. Welcome, guys. Welcome. Hello, Star. Hello, guys. Welcome. Right. Oh, Thomas does AS Maths. Nice. Right, guys. We shall make a start then, okay? If anyone here, is coming actually from YouTube, then please let them know, that I'm doing it on here, okay? So, Serafina, I think that's right. Yes, that right. Yeah, has got an answer. So let's double check. So, question number one: for us to simplify, okay, 125x to the 6 all over 64 to the power of 1/3. So, power of 1/3 means I'm going to take the third root or the cube root. Okay, sorry guys, about my little pad. Okay, of this fraction. Okay, and we'll do it obviously piecewise here, so piece by piece. Okay, so cube it at the top, cube it at the bottom. Okay, separately. So the cube root of 125 is 5. The cube root of 64 is going to be 4. And the cube root of x to the 6, well, if it's a power to a power, then I multiply. So 6 times 1/3 makes x squared. So it's 5x squared over 4, or 5/4, yeah, x squared. Okay, so well done, Safina. Okay, that's question 1 done. Okay, question number 2. So simplify. Okay, now guys, yeah, just actually a little disclaimer. So I am gonna skip here some questions because I'm quite keen. If it's easy in Matai, feel free to obviously move on. That's fine. Okay, so simplify 2x to the power of half, all cubed over 4x squared. So now I'm going to do 2 cubed. That's 2 times 2 times 2, which is 8. Then we have x. Oops, sorry, apologies. Sorry. Then we have x to the power of a half, all cubed. So that'll be x to the power of a half times 3. So that'll be 3 halves. 3 over 2. All over 4x squared. Okay. So remember, yeah, numbers go with numbers, yeah, letters go with letters. 8 divided by 4 is 2. And then x to the power of 3 halves over x squared. I'm going to subtract the powers. It's the same base. So 2 wholes is 4 halves. So I have 3 halves, subtract 4 halves, which is minus a half. Okay, a negative a half. So I can write it as that, or I can just write it as 2 over the square root of x. Okay, either answer would suffice. Okay, does that make sense, guys? Does that make sense? Ooh, sorry. Does that make sense? Let me know. Any questions? Okay. Let's look at question number 3. Hello, Katie. Welcome. Thank you. Thank you, okay, for sharing. Okay. So question number 3, okay, slightly more trickier. 216 x to the power of 6 all over 27y cubed to the power of negative 2/3. The negative makes it the reciprocal, so if you turn it upside down, we're going to have 27y cubed over 216 x to the power of 6, and then to the power of positive 2/3. Okay, I won't be doing P3, yeah, P3 today, so I apologize. Okay, I'm doing obviously AS maths today, but I may think about it, yeah, in like another live. Okay, if it's quite popular, but yeah, not today. Okay, sorry about that, not today. Yeah. Right, next one. So, what does power or powers of 2/3 mean? It means the cube root of this fraction, and then I'm going to square it. So the cube root, okay, of 27y cubed all over 216 x to the power of 6. Okay, and I'm going to square all this. Okay, again, I'm going to do it obviously in one go. There's a lack of spacing here. Oops, sorry. There we go. So, listen carefully, guys, and obviously watch carefully. Okay, so the cube root of 27, yeah, that'll be 3. The cube root of y cubed is going to be just y, okay, over the cube root of 16, that'll be 6. The cube root of x to the 6, well, that should be x squared. Okay, so you're dividing here the powers here by the letters. Okay, and then I'm going to square the answer. So I'm going to have 9y squared over 36 x to the power of 4. And then I can simplify, yeah, if I want to, okay, but I leave it as that. But yeah, divide top and bottom by 9, and you get 1/4 y squared over x to the power of 4. Okay, either answer would suffice. So you get 1/4, by top and bottom by 9. I get that, okay? So that is question 4 done, okay? So question 3 done, okay? So I'm not going to do every single question, guys, here, because, yeah, obviously, yeah, the focus for today is to cover, yeah, a wide range of topics. That is the plan, okay? So I'm gonna do 2 questions here from each section, then I'm going to move on, okay? So that's the plan. Question number 4. Express 9 to the power of 3x plus 2 in the form, okay, 3 to the y, where giving y in the form ax plus b, where a and b are constants, okay? So 9 can be written as a power of 3, so 9 will be equal to 3 squared, to the power of 2, because 3 squared here means 3 by 3, which is 9. And I've got 3x plus 2. Remember, yeah, guys, yeah, from GCSE maths, okay, a power to a power, then we multiply, okay? So that will be 3 to the power of 6x plus 4, okay, where a is 6 and b is 4, okay? Next one, express 8 to the power of 2x minus 5, okay, in the form 2 to the y, giving y in the form ax plus b, where a and b are constants. Hello, Olivia, welcome. Hello, Michael, welcome. Okay, so 8 can be written as 2 cubed, so we have 2 cubed, okay, all to the power of 2x minus 5. Okay, again, when it's a power to a power, okay, the index rule, yeah, states that I can multiply the powers together. Okay, so that'll be 2 to the power of 3 times 2x, so that'll be 6x. And then 3 times minus 5 makes minus 15. Okay, and that, guys, is my answer to question number 5. Okay, so again, these are questions here that will appear at the start of an AS Pure Maths paper. Okay, right, next one. Question number 6. Okay, so given that y, well then, okay, yes, spot on. Okay, well then, yep, good job, my friend. Okay, so given that y equals 2 to the x, express 4 to the x in terms of y. Well, 4 is equal to 2 squared. So we have 2 squared, okay, all to the power of x. Now I can just swap these around, so I can rewrite it as 2 to the power of x all squared. Well, y equals, yeah, hello Leah, welcome. Well, y equals 2 to the x, so that would just be y squared, okay, and that's part A done. Okay, so that's expressing as a power of 2. Okay, next one, guys. Hence or otherwise, solve the equation 4 to the x minus 6 brackets 2 to the minus, 2 to the x minus 16 is equal to 0. So this is going to be a hidden here or a disguised quadratic. Okay, so if we let y equals 2 to the x, we're going to have y squared minus 6y minus 16 is equal to 0. I've got a quadratic here which I can factorize, complete the square, okay, or use a quadratic formula, okay? So that's going to factorize into y minus 8 times y plus 2. That will be equal to 0, guys, okay? So my two solutions for y, guys, will be as follows. It'd be y equals 8 or y is minus 2. Now, I know that I've said that y equals 2 to the x here as a substitution. Okay. So 2 to the x equals 8. And 2 to the x equals minus 2. So this second one has no real solutions. Okay, so I can ignore that. Okay, so x in this case, x is equal to 3. Okay, and that's my only valid solution to this disguised or hidden quadratic. Okay, because you can't solve an exponential where it's 2 to the power of something equals minus. Okay, so that's question B done. Okay, right, let's skip a few. So let's obviously skip a few. Okay, right. Let us try question 11. Okay, so factorize completely x minus 16x cubed. Okay, so step 1, pull out a highest common factor. Okay, so that'll be x. So x brackets what x times what makes x, what x times 1 makes x, and x times what makes minus 16x cubed. That'll be minus 16x squared. And hopefully you can see now that is, a disguised or a hidden given to two squares. So that'll be x brackets 1 plus 4x times 1 minus 4x. Okay, and that is the fully factorized version of that cubic expression. Okay, so watch out for those in your AS pure maths papers. Okay, so whenever it says factorized completely, so always pull out the highest common factor and then check if the bit is at the bracket also factorizes. Okay, let's see question 12. Factorize completely 75x minus 12x cubed. So again, pulling out highest common factor. Well, that will be 3. Then I can pull out an x as well. So 3x times what? Okay, makes 75x. Well, 3 times 25 makes 75. Times it by the x makes 75x. And the 3x times what makes minus 12x cubed. Well, that'll be minus 4x squared. Okay, again, I've got another hidden here or disguised here. Dots, okay, so difference of two squares. Now 3x brackets the square root of each term. So 5 plus 2x times 5 minus 2x. And that, guys, is the fully factorized factorized cubic of 75x minus 12x cubed. Okay, does that make sense, guys? Yeah, are there any questions? Hello, Ella, welcome. Okay, next part. So expanding triple brackets. Okay, so quite nice and easy, I think it is. Okay, let's do this one to make it a bit more fun. Okay, so expand and simplify 3x minus 2 times x minus 5, all squared. So that'll be 3x minus 2 times x minus 5 times x minus 5. Okay, so do 2 brackets at a time, guys. Obviously, check your answer. Okay, pick whatever two you do. Okay, so 3x times x makes 3x squared. Okay, 3x times minus 5 okay, makes minus 15x, okay, minus 2x, that makes minus 17x, okay, and then plus 10, okay. Hello, Charlie, welcome. Hello, AZH, welcome, my friend. Hello, Sadia. Okay, I'm going to times that by x minus 5. Okay, again, I'm running out a bit, obviously a bit of room here, so let me just zoom out a bit. Okay, let's obviously just change colours so we can see a bit more clearly. So 3x squared, times x, that makes 3x cubed. 3x squared times minus 5 makes minus 15x squared. Minus 17x times x makes minus 17x squared. Minus 17x times minus 5 makes positive or plus 85. Okay, x. 10 times x makes 10x. And then 10 times minus 5 makes minus 50. Okay, I can now collect my like terms. Okay, so I'm going to have 3x cubed minus 15, x squared, minus 17x squared makes minus 32. Okay, x squared. 85x plus 10x makes 95x. And then we've got that minus 50 there. Okay, so that, guys, is expanding, and obviously going over expanding triple brackets, okay? So again, another important skill for AS Pure Maths, okay? So does that make sense, guys? Are we happy with that, okay? So looking at some algebraic expressions for the AS Pure Maths course from Maths Genie. Okay, let us try question 15. Okay, let's just delete this now. Are there any questions, guys? Does it make sense so far? Okay, so we are covering a wide range of topics today. Okay, from the AS Pure Maths course, the first few chapters. Okay, guys, any questions? Please let me know. Okay, I'm happy to help you and support where I can. So for AS Maths I would say Maths Genie. Okay, Maths Made Easy. Check out TL Maths. Check out Bison Maths. And but I would say Maths Genie, Maths Made Easy. And I think TL Maths here is pretty good actually for A level maths. Okay. Guys, can we try and smash 10k likes, okay, in the next 20 minutes, okay? That's our target. So can we try and get 10k likes today? No worries, okay, no worries. Right, question 15, okay? So find the value of x such that 1 plus x over x equals root 5, giving your answer in the form a plus b root 5, where a and b are rational numbers. Okay, so written as fractions, or whole numbers. So step 1, times it both by x. I'm going to get 1 plus x equals x root 5, or root 5 lots of x. Okay, subtract x on both sides. Okay, so I'm going to get 1 is equal to x root 5. Hello, Lydia, welcome. Okay, subtract x. I'm now going to factor out the x, guys. I'm going to factorize out the x. So now 1 is equal to x brackets root 5 minus 1. And then I'm going to divide, by root 5, minus 1, on both sides. Okay. When I do that, we get x is equal to 1 over root 5 minus 1. But are we finished there, guys? We're not. So we have to actually rationalize this. Okay. So times top and bottom by the conjugate of the denominator. So times top and bottom, by the denominator, but obviously flip the sign. So we're going to have 1 over root 5 minus 1 times by root 5 plus 1. Okay. Over root 5 plus 1. Okay. So when I do this, it causes, us no longer to have the third on the bottom of the fraction. Okay, when we expand it. So on the top, you have 1 times all this, that'll be root 5 plus 1. Okay, or 1 plus root 5, either way will be fine. Okay, and on the bottom, all we do is we do this times this minus this times that, okay, because middle terms, end up actually cancelling. So root 5, times root 5 would just be 5. Minus 1 times 1 will be minus 1. So we have 1 plus root 5 on the top over 4. And then obviously writing the answer in that form, we're going to have 1/4 plus, plus 1/4 root 5. Okay. Where A is a quarter and B is a quarter. And that, guys, is my final answer, okay? That is solving an equation, involving, rationalization, okay? Does that make sense, guys? Are there any questions? Let me know in the chat. Any questions? Let me know, please. Or can I move on? Hello, Samaya. Welcome. I'll take it as a yes. Okay, let's miss this one, because I'm pretty happy, I think, with all this, okay? So let us try question 19. Okay, it is yes. Okay, thank you for that. Yes. So first class maths is pretty good, actually. Yes. So I recommend, first class maths as well. Okay, for GCSE maths, and A-level maths. So express as a single power of a cubed over the square root of a. Well, the square root of a can be written as a to the power of a half. We're going to have a cubed over a to the power of a half. I'm dividing here with the same base, so I can subtract the powers. I'm going to have a to the power of 3 minus half, which is a to the power of 2.5, okay, or 2.5, which is the same as 5 halves. Okay, so that is expressing as a power of a. Okay, so remember that the square root of a letter, the square root of x, can be expressed as a fractional power, x to the power of a half, okay, or positive half. Okay, if it's the cube root of, let's say, 7, then I can write it as 7 to the power of a third. Okay, that is fractional powers. Okay, there we go. Right, next one. Identify the expression that is equivalent to a to the power of minus 3 halves. Well, the minus makes it 1 over, so it's 1 over a to the power of 3 halves. which is 1 over, okay, the square root of A all cubed, okay? Now, this is the same as writing it as, okay, so think of a power of 1 here, 1 over the square root of A cubed, okay? Because 1 times 3 makes 3, okay? So it's going to be that one there, okay? So it's always the root of the bottom and then raise it to the power of the top, okay? Right, next one gets slightly more trickier now, okay? Let's actually zoom in here so you can see a bit better. Solve the equation x to the power of minus a half equals 3/5, giving your answer as a fraction in its lowest terms. Okay? So, what's the opposite of a negative of a half? Okay, so probably minus half. Well, that would be to raise it, to the power of minus 2. Okay, so if I raise both sides of my equation to the power of minus 2, okay, that will cause these to go to 1, okay, and then this will become 3/5 to the power, of minus 2. So on the left-hand side, well, a power to a power is minus a half times minus 2. That becomes a plus. A half times 2 makes 1. So that just becomes, x to the power of 1, just x here on the left-hand side equals 3/5 power of minus 2. Well, the minus flips, okay, does the reciprocal. So that would be x equals 5 over 3 or 5/3 all squared. Hello, time tutor. Welcome, my friend. Hello, hello. Okay, so square the top, square the bottom. So I'm going to get 25/9, okay, which is right here as a mixed number. So that'll be 2 wholes, okay, with a remainder of 7, 2 and 7/9. Okay, next one, okay. Might actually skip your question 22 for now, then I'll come back to it. Okay. Well, question 22, okay. Without using the calculator, prove that 2 root 5 is greater than 3 root 2. Well, I know that root 5, okay, is between root 1 and root 4. Root 4 and root 9, I mean, sorry. Okay, so root 4 is 2, root 9 is 3. So root 5, I would say is a rough estimate, let's say, okay. Hello, Michelle, welcome. Okay, maybe even just 2.1, I should just call it, let's call it 2.1 I should for the sake of argument. And then root 2 is about, let's say 1.3, okay, as an estimate, okay, rough guess, okay, or even 1.4. Well, 2 lots of 2.1, okay, that'll be 4.2, and then three lots of this, okay, so that will also be 4.2, okay. But I've obviously done some actually, like rounding here, I'd say. So this is actually closer to 1 point. So this is roughly a 1.41. Okay, and then I would say this is roughly maybe like 2.16 here. So let's call it 2.2. anyway. So that'll be 2 times 2 by 2, so that'll be 4.4. And then 3 times this. That'll also give you 3 Is that right? Let's just double check. Got 3, 12, carry the 1. So 4.23. Okay. Again, I've done, so actually look like you're rounding errors here. Yeah, let's say that's 2.23, let's say. And then there we go, bang, that will now be bigger than that, okay? But yeah, don't panic here, okay? So that was a bit of, like a weird question, I'd say. Okay, right, let us try question 23, okay? So given that 4 to the power of 3x minus 1 over 8 to the power of y plus 2 equals 16, express y in terms of x, giving your answer in its simplest form. So our aim is to get y equals f of x. So y is a function of x. So first step, write everything here as a power of 2. So 4 will be 2 squared. We've got 2 squared brackets 3x minus 1 over 2 cubed. Okay, times it by that. So that'll be 2 to the power of 3y plus 6. That's equal to 2 to the power of 4, okay, which is 16. Okay, let's obviously expand the brackets out. So that'll be 6x minus 2 on the top. Now when I'm dividing with the same base, I can minus the powers. So we got 6x minus 2 minus 3y minus 6. That'll be equal to 4 by definition. Okay. Put the y here on this side, and put the 4 on this side. So we're going to have 6x minus 2 minus 4, makes minus 6. That'll be equal to 3y. Okay. Divide by 3 on both sides. We have y is equal to 2x minus 2. And that, guys, is the fully simplified answer, okay? So that is my answer for question 23. So y is equal to 2x minus 2, or 2 lots of x minus 1. Okay, question 24. Show that root 5 over root 3 plus 2 can be written as form a minus root b, where a and b are integers. So again, obviously think of rationalization. So times top and bottom here by the conjugate of the denominator. So times it by this, obviously flip the sign. Okay. Hello, Abby, welcome. Okay. So when I do this, what am I going to get? Well, I create, the difference of 2 squares here on the bottom. Okay. So what we're going to have? Well, we're going to have root 5 times root 3, so that'll be root 15. And then root 5 times minus root 2, that'll be minus root 10. All over root 3 times root 3, that'll be just 3. And then subtract root 2 times minus root 2, so that'll be minus 2. Final answer here is going to be root 15, subtract root 10, over 1, which is just root 15 minus root 10 as our final answer, okay? So that, guys, is how we rationalize, a more trickier type of surd. So you multiply, top and bottom of the fraction by the conjugate, okay? That's my answer for that question, okay? Right, let's look at some more nastier questions, okay? So, we've done quite a bit of obviously surd so far, okay? Right, let us try this here, okay? So this one here is a bit more trickier, okay? So find, using algebra, all the real solutions to the equation part I, a squared equals 8 root a. So so let's write here as a squared subtract 8 root a, or 8 to the power of a half, 8 to the power of a half, sorry, equals 0, okay? So let b equal a to the half, okay? Is that going to work? Well, let's check. Hello, George. Welcome, my friend. Hello, Janelle. Welcome. Okay, is that going to work? So, to go from half to 2, okay, I've raised it, to the power of 4, okay? So, here, b to the power of 4, okay, equals a to the power of a half to the power of 4. So, a half times 4 makes 2. We're going to have a squared there. So, this will read as b to the power of 4 minus 8b is equal to 0, okay? Factor out b, we have b brackets, b cubed minus 8 is 0. So either b is 0 or b cubed minus 8 is 0. So either b equals 0 or b equals 2. Okay? Because then you have b cubed here minus 8. Okay? Is equal to 0. So if b is 0, then a will be equal to 0. If b is 2, so if 2 equals a to the power of a half. Hello, Kez. Welcome back, my friend. Hello, hello. Okay. Well, the opposite power of a half, is to obviously square both sides. So a will equal to 4. So your two solutions, to this disguised quadratic is when a equals 0 or a equals 2. Okay. So that is that is quite like a nasty like way of like answering that question. Okay. That one, okay. What about part B, I? So slightly more easier, I think, okay, better than the first one, I'd say. So this one, think of it as a quadratic, but instead of writing B, you write B squared. Okay. So this is more A-level maths here, so A-level maths. Okay. So B squared in one, B squared in the other. Okay. So two numbers that add to equal -5 and times to make -14. Well, that would be +9. Okay. And -2. Okay. So either b squared, plus 9 equals 0, or b squared minus 2 equals 0. Well, that has no real solutions, okay, so I can't actually solve that. So my only solution here will be b is equal to plus or minus the square root of 2, okay? So think of it as b squared minus 2 equals 0. Add 2 to both sides, okay, and then square root it. You have b squared equals 2. What's the opposite of squaring? That'll be to square root both sides. So b is equal to plus or minus the square root of 2. And that is the only real solution here to my quartic. Okay, the other two are technically what we call complex roots, but that is obviously beyond the scope for A level maths. Okay, but so it has two real solutions. Okay, and then it has two complex solutions. Hello Ruby, welcome. Hello Jordan, welcome guys, welcome. Okay. So these are quite sneakier, like quadratic in this case. So solve the equation x cubed plus 3x to the power of a half, 3x to the power of 3 halves minus 10 is 0. So this to me, in my head, we want to try and get to a position where we have x squared plus 3x minus 10 is 0. So what substitution here have we done power-wise to go from here to here? Okay, well, to go from 3 to 2, okay, as a power, okay, and I raised everything to the power of 2/3. So let's say um yeah let's call it like x1 okay, so x1, okay, so let x1 equal x to the power of 2/3. Okay, is that right? Sorry, is that right? No, what I mean is, sorry, let's actually call it y, sorry, not x1 here, because it is going to be obviously actually a bit confusing there. So let's obviously call it y. So now we'll have y squared. Hello Zishan, welcome my friend. Okay, plus 3y minus 10 is 0. Okay, factorize that and have y plus 5 times y minus 2. Hello, Orion, welcome back, my friend. Hello. Is that right, guys? Yeah, for my substitution, is that right? Or should it be, or should it be y to the 2/3 equals x? So obviously, flip the sign. So y is equal to minus 5, or y equals 2. Okay. Now, where do we go from there? Let's just double check it. I'm doing this right. Sorry, guys, give me just 1 second just to double check. I think I'm hello Amelia, welcome. I think I'm actually right, guys. Yeah, I'm just double checking that my substitution here is done right. Yeah, that is right. Yeah, yeah. So that is actually right. Yeah, I was just double checking. I am right. Yeah, I am right. I was just double checking. I apologize about that. So we have x to the power of 2/3 equals -5, or x to the power of um yeah equals -5, or x to the power of 3/2 or 2/3. Sorry, equals 2. That one has no solution. Yeah. So that one has no solutions. Okay. That one will be, well, raising, yeah. Second case, so raise the to the power of 3/2. Okay, so x equals 2 to the power of 3/2. And that is my solution to this, yeah, hidden, yeah, quadratic key question. So someone's got a question. Don't you mean x to the 3/2? Uh, not 3/2, because no, because if you think about it, yeah, if you think about it, if I if I- so if y equals 3x 3/2, then that part there, because 3 doesn't go into year 3.5 year. Does that make sense? I have checked the mark scheme here, and they got the exact same answer as me, so I am certain. If you let y equals x to 3/2, then you'll get a 3y here, but then this will just go to 3/2 to 3, or 3 will equal to 6/2. So you times that by 3, but you can't do that, okay, because you can't change the subbing, okay. Hello, Abs. Welcome, Abs. Don't panic. Don't worry. Don't panic. Hey, these sessions are trying to obviously plug in the gaps here for A-level maths. Okay, so AS pure maths. Okay, right. Let's do question 30I. Okay. Hello, Ames. Welcome, my friend. So, solve the equation x plus root 12 equals x plus root, sorry, equals x root 3. Okay. Your answer is again in its simplest form, or root 12. So yeah, so let's obviously minus here, minus x on both sides. So we're going to have root 12 equals x root 3, subtract x, factor out the x. Okay, so root 12 here, okay, is equal to x lots of root 3 minus 1. Divide by that, yeah, obviously on both sides. So we're going to have root 12 over root 3 minus 1 is equal to x. Okay, I can now obviously rationalize this, okay, but before I do, let's obviously write this here as root 4 times root 3. Okay, so that'll be 2 root 3 here. Okay, because root 12, okay, is root 4 times root 3. Okay, check here if you're unsure. Okay, so that'll be 2 root 3. I'm not going to rationalize the denominator, so times top and bottom by the conjugate, okay, of the denominator. okay? So times top and bottom by root 3 plus 1 over root 3 plus 1. Or what we're going to have on the top, hello m, welcome m. We're going to have 2 root 3 times root 3. Well, root 3 times root 3 will be 3. Times by 2, that'll be 6. Plus 2 root 3 times 1, which is 2 root 3. Over, remember my trick, guys? Okay, it's this number here. So this times this, subtract that times that, okay? So root 3 times root 3, that'll be 3, okay, minus 1 times 1, which is 1,